So I got a message the other day. I forgot to reply, but it's basically a pre-pharm student asking how hard the chemistry is in pharmacy school because they've heard it was pretty tough. And I'll be honest with you, it was one of my favorite subjects. So for me, I didn't think it was that difficult, but there's just a lot to learn in a short amount of time. And just to kind of give you an example, I'm going to show you some notes on morphine because that's just what the first thing that popped up. So basically, it's just a review of Orgo, like Orgo 1, where you learn your names from, where they come from, and all that stuff. So just looking at morphine, it's broken up into 5 different rings. You have A, B, C, D is up here, and then E right there. And basically, with everything that's attached to it, it gets its name. So for example, morphine is considered 4,5-alpha-epoxymorphinan. The thing is, there's a lot of derivatives of morphine. So you're going to see a lot of different changes, and how they change that is either in the A ring, some positions in the C ring, or any kind of nitrogen substitutes, which is all the way up here. One cool thing about morphine is that it mimics these peptides that work endogenously, or naturally within our body. So that's how it gets its function. A little quick overview on morphine metabolism. Basically, it undergoes dealkalization and glucuronidation. What that means is, up top here, you have N-methyl group, and it takes away that methyl group and just leaves it with NH. And then glucuronidation means it adds a sugar moiety to this side and on this side, but the 3-glucuronidation is actually inactive, and the 6-alpha glucuronidation, which is this guy, is going to be more potent than the actual morphine itself as an active metabolite. So this is going to be another example of just basic organic chemistry. If you're looking right here, there's a double bond in a boat position, and here in a chair position. Basically, this is where their names get their names from, oxycodone and hydrocodone. So that red circle right here, where is it? Right there. If there's an OH group at that circle, it's going to be oxycodone, and the one comes from that double bond right there. And then if it's a hydrogen group in that same position, it's going to be hydrocodone. And that's basically where it gets its name from. I'd say that's about the extent of our med chem, but just with all the other drugs. So it gets interesting to see how the mechanisms kind of play into their names and how they actually work and the side effects and all that fun stuff.